Hey leaders, it's week 8, time for another business checkup. And this week we want to talk about the concept of takt time. So takt time is the operational heartbeat of a production process. It represents the maximum amount of time to produce a product so you can still keep up with customer demand. This helps us balance our operations so one, we don't run into shortages or back order, but also we're not overproducing against what the market is expecting of us in terms of orders and fulfillment. Now, this pace needs to be maintained more than just one day, and ideally, all of the enabling processes and your suppliers would be able to operate at the same pace to optimize productivity and quality. This enables the smoothest flow of product and theoretically the ability to lower inventory levels to not have to buffer between changing levels of productivity. But where did this concept come from? The word Takt is actually German, where it talks about a pace or an interval. The first time we see this come up is in 1926, so it's referred to as Takt, which really means time interval or cycle time and translated into English. And after World War I, the German Air Force is producing planes, and one of the contractors, Junkers Aircraft Works, is using a system where it has specialized teams that are moving synchronously on pace through the planes in order to deliver one plane every 9 hours. And this was groundbreaking for the time, getting away from craft production and moving towards mass production, but also balancing the work so we can get it all done. So Takt as a manufacturing concept first comes on the page in the 1920s. Then as subassemblies were introduced into that same airplane factory, they were timing or pacing the subassembly lines that fed into the main assembly line and setting all at this set interval they called Takt. And at almost the same time and completely independent to Germany, the Ford Motor Company was supporting the US military as well. And at the Willow Run facility, they were producing the B-24 Liberator, and they actually got to this similar concept of a synchronized or a paced production system, and they got down to the point where they were producing one completed airplane every hour, completely blowing out any productivity that they had seen before that. Now, there's a selection of other tools and concepts that enabled this pacing, but it had to synchronize the assembly and subassembly lines to some pace or interval that we refer to today as Takt. Now, Toyota developed this principle when they were architecting the Toyota production system post-World War II recovery. So a great concept that now Toyota brings into the fold and really perfects so that through modernizing their production control, they would increase production capacity without increasing employees to do that. And this concept took on the standard that we recognize today in terms of takt time. So how do we calculate takt time today? Because takt is a time interval, it's measured in units of time, commonly in minutes or seconds for most production processes I've been around. To arrive at this production time target, we have to take the available working time in a day and divide it by the number of products required to meet demand in that interval. For example, if you take one 8-hour shift and divide it by the average daily demand, if you remember, we talked about average daily demand in week 6 and why it was important. Here's the first time it comes back. We're able to figure out how much time is allowed across the interval of each production unit to produce. But wait, operations isn't productive the full 8 hours of the shift. We need to debit some of that time out that's required for start of shift meetings, breaks, mandatory cleanup. So let's walk through an example. If we have an 8-hour shift, that's 480 minutes. If we take off a start of shift meeting for 10 minutes, 2 10-minute breaks for a cumulative 20 minutes of breaks, and 15 minutes for cleanup and standardization at the end of the day, we arrive at 435 minutes. So now, rather than 480 minutes of available time, I have 435. If I assume my average daily demand indicates I need to produce 100 units within that shift to keep up with customer orders, I take the 435 minutes divided by the 100 units of demand to arrive at 4.35 minutes or 261 seconds. This is the maximum allowable time to produce every unit and still keep up with customer demand and not overproduce. The goal of production now is to pace production to the actual time so that the cycle time of operating our production processes is aligned with that takt time. So cycle time and takt time, when they're perfectly aligned, then any disruption in your process actually means I'm falling short of customer demand. We recover that time with additional or available hours. So that's shift work to cover production shortages or planned overtime. Now, because I've seen companies decrease available time to account for disruptions, sometimes you have things like line-side part shortages, in-process rework, other normal disruptions to your production operations. The effect would be allowing some percentage of non-productive time within the shift. One company I supported called this an operating ratio, where they only accounted for 80% of the available time, meaning they were going to plan for 20% downtime due to equipment, part shortages, quality issues, things of that nature. This, they said, enabled them to recover within the planned hours to meet it. However, I caution against this tactic for two reasons. The first reason is that it creates a false urgency on your takt. If I take time out of my available time, my takt time gets shorter. So now my standard work needs to move faster to keep up with it. The second thing is that it removes urgency from problem solving. So if I have this buffer built in, the problems I have with machine breakdown and parts availability and quality become less urgent because I can still hit customer demand. So we want to shift the focus onto problem solving those things that get in the way of hitting our standard. So one more thing before we talk about bringing this into your production is the concept of batch size and cycle time, and how does batch size relate to takt. So although smaller batches are promoted and desirable to maintain flexibility in a production system and reduce your overall plant lead time, the time a part needs to move through all of your production steps, some equipment is designed to run multiple units at a time. And so when we run a batch through a particular operation or piece of equipment, we must consider the effective cycle time for the part. So let me explain. I saw a funny post this week from a friend of mine, Mark Graben, that said, you wouldn't boil spaghetti one noodle at a time. Of course not. We have some operations that similarly are designed to run in batches. If I think about something that I've seen would be a heat treat or a curing process, where say you're curing an adhesive or a sealant. In that situation, let's say that we put 30 units at a time into our oven, and the cure time or cycle time for that oven is 90 minutes. So now the effective cycle time for a part is that 90 minutes divided by the 30 units that we're producing, which is 3 minutes. So effectively, we can supply our customer one part every 3 minutes after that batch is complete, and we will have completed the next batch to replenish our stock. So this effective time, not the oven cycle time, is what we would compare to takt time. As we know previously, that this is well within our assumed takt time from an earlier calculation of 4.35 minutes, so we have plenty of buffer in order to run this operation. Okay, so what? Takt is a target. Takt started in Germany, was perfected by the Japanese. What does this mean to me? Takt is a target. We need to design our production processes to meet some target of production to meet a known level of demand. This implies that the standard work for our operations and the standard times associated with them should be designed to meet that target, that takt time. Now, standard work with standard times provides stability for our operations, and not only operations, but also supporting processes and our suppliers. When we level load production, it creates predictability where we can optimize our productivity and our quality. So the takt should not change every day or every week or so frequently that the production target on the line, if I have true standard work, I shouldn't ask operators to produce at one rate on Tuesday and a different rate on Thursday. But will your demand change? Of course it will. But let's not knee-jerk react to changing our demand. Let's cover spikes in demand with additional hours through planned overtime or shift work. If the demand truly has shifted, great. Let's recalculate our takt time. But remember, this implies you also need to go back to redefine your standard work and rebalance your lines. That's not a small feat. To give an example, rather than changing demand and takt on a regular basis, one client I supported had fluctuating demand. They were a made-to-order business, and it strongly relied on the arrival of customer orders. So when large customer orders would come in, demand and daily targets would go up. When it would lull down, they would maintain the same operations but drop the target. So this was frustrating to the operators with the daily changing targets, and it created a situation where they were plagued by quality issues. Work faster on Tuesday, slower on Thursday, and a little bit faster next week. In analyzing the demand, I recommended to that client that they create 2 levels of standard. So their highest demand quarters were actually the first 3 months of the year, January, February, March, and the last quarter of the year, October, November, December. So we created a standard with a higher demand, a shorter takt time, to operate in those 6 months of the year. And during the middle of the year, quarter 2 and quarter 3, over history, we showed a lower demand. So we created these 2 levels, a high demand and a lower demand offense to run with a constant takt time and pre-balanced standard work so that they could decide when to switch from one to the other. Now, for you, understanding the history and purpose and use of takt is important. Measuring your average daily demand, knowing the available time that you have, can help you in designing and improving your production processes. When we do this, it's clear where we can and cannot meet customer demand. That enables us to focus. And where we can focus, we can better improve less and get better results. I'll see you next week.